Intro Algebra Lesson 5-4A. We've now taken all the steps from the beginning to this point where it was very easy. Given a slope, given a y-intercept, you substitute the values in and you were able to write your equation in y equals mx plus b slope-intercept form. Then it got a little harder. You were given the slope and you were given a coordinate, and you could use the two to find the y-intercept and then write your equation in y equals mx plus b form. Then we stepped it up a little bit harder, and instead of given the slope or given the y-intercept, you were given two coordinates, of which you could take the two coordinates, find the slope, then use that slope and one of the coordinates to find your y-intercept and write your form of slope-intercept form. Today, we take this idea and we relate it to situations where scatter plots would be involved. And that brings us into the idea of what's known as a best fitting line, or a line of best fit. A line that is as close to the scattered points as possible. As many points on the line as possible. Be sure your line has 2 points that you can read off of it very easily. So, we've already talked about scatter plots in the past. Scatter plots are different than something that's linear, that makes a nice straight line. Scatter plots have points that are all over the place. But there may still be a trend of the points. They may still be going in a direction or a relationship from left to right, or possibly down. And our job when we see a bunch of these scattered points is to try to find a line that seems to be as fair as possible to all of them. Now, if I grab a line and go like this, that's not really fair to as many of the points as possible. So I might adjust it. Maybe I come over here and I say, okay, there, I've got, that line goes through some of them, but it's not very fair to the rest of these. If I move the line down here, it's not very fair to the points up there. I need to find something that is as fair as possible down the middle of them. And it seems to be as equidistant as possible to all the points. So this line is as best as I can do to make as many points as possible happy. I'm not going to be able to make all the points happy and let them be on the line, but I can try to make as many points as possible, or at least close to the line as I can. Now what would be ideal is if I look at it and I go, oh hey, here's a point and there's a point, because that's what I need. I need at least 2 points that form this line, because if I have 2 points, I already know that I can write an equation for it. It won't be an equation, there will not be an equation that lets me get all these dots. It'll allow me to get something somewhat close to the dots. So we have a situation. We have the age of a tadpole. This is the days that it is old, and the length of the tadpole. You might notice that as the tadpole is older, 12 days is older than 2 days, the tail is not as long. And that's because the tail on the tadpole shortens as it becomes the frog. So this relationship is, as it gets older, the tail is getting smaller. So what we might want to start with is taking that information and putting it on a graph. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 days that I can put across the bottom. And I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we'll say this is the millimeters of the tail. So I'm going to plot these points. These are actually coordinates. So I have a 5 that goes up 14. So if I go up 5, 11, 12, 13, 14. And 2 is at 15. 9, 1, 2, 3. 7, 2, 4, 6, 8. 12 is at 1. 10 is at 3. 3 is at 12. And 6 is at 9. So there we have a scatter plot. There's definitely a relationship. As the tadpole gets older, the tail is getting smaller. It's not a perfect straight line though. So I could try and make a line at best fit, and I could say right there, Well, that's great for these two lines, but it's not very good for the rest of this graph. I could go, all right, how about those two? Yeah, it's a little bit better in terms of the relationship, but it's still not very fair to the rest of these. So I move it, maybe I go here, maybe I move it there, something like that. Seems a little better, maybe. So in all honesty, there may be some differences from one person in the room to another because it depends on how they choose. Now, I'm looking at this saying, I've got 3 dots on the line, one very close. This one's not too far, not too far. That one's the farthest, but it's not too bad. That's a pretty decent line of best fit. Now what I notice is, I have 2 coordinates that I can pick off of here. This is at 6, 9, which is right here. And this one is at 10, 3, which is right here. Now if I go back to what I already know how to do, I can take these 2 coordinates and I can find the slope. So 6, 9 and 10, 3. 6, 9 and 10, 3. So I take 6, 9 and 10, 3 and I'm going to make a equation based on that information. So I label x sub 1, y sub 1, x sub 2, y sub 2. And we know we always have y sub 2 minus y sub 1 on top, x sub 2 minus x sub 1 on the bottom. So this will equal my y sub 2 that I've labeled is 3, my y sub 1 is 9. My x sub 2 that I've labeled is 10, my x sub 1 is 6. So plus the opposite, we end up with negative 6 over 4. Now that can be simplified down. That's the same as negative 3 over 2. Now that's a negative slope, which means as you look at it from left to right, it goes down, and that matches up. If I go down 1, 2, 3, and 1, 2, I'm on the line. 1, 2, 3, and right 2, I'm on the line. So it definitely works that that's the slope. I use that slope and one of the coordinates, so I'll use this coordinate here. So I'll use 6, 9, and I'll say 9 is equal to that slope times my x plus b. This is exactly like what we've been doing. I can make that a fraction. 2 goes into itself once and into 6 3 times. 9 is now equal to negative 9 plus b. So I want to get b alone. Add 9. Add 9. 18 equals b. So now I have a slope and I have a b value. My final equation, y equals negative 3 over 2 x plus 18. And that equation allows me to make predictions about the size of tail based on the age of the tadpole. If I were to use my equation and say, well, in 10 days or 12 days, if I do 12 days, then negative 1.5 of 12 is actually going to be 18. So I would have 18, negative 18 plus 18 would make 0. So in 12 days, I should have no tail. There's 10 days, there's 11 days, there's 12 days. And according to this graph, in 12 days, I would have no tail. So it works. Now up here, it said that in 12 days, there was still 1 millimeter of tail. That's because that's that dot right there. It's not perfectly on the line. It won't always match up perfectly. This is an approximator. I can also think about my y-intercept is at 18. If this line were to continue, 16, 17, 18, so according to this, at 0, when the tadpoles are just born, they're roughly going to have 18 millimeter tails that get smaller as they get older. So again, we use it as a predictor. This is not an exact amount for every tadpole that exists. It is based on the data and how we use that data to come up with our equation for that real life problem. All right? Correlation is just a fancy way of saying a relationship or a connection of two different things. We can apply that to X and Y. Here, there was a correlation between the age of the tadpole and the length of their tail. The correlation or the relationship or the connection was, as the tadpole gets older, the tail gets smaller. That was the correlation. That was the connection. So when we look at this type of scatter plot, we would say there is a positive correlation. As it's getting bigger, so as X is getting bigger, so is the Y. We would say this has a negative correlation. As you look at it from left to right, the dots appear to be going down. So as one is getting bigger, the other is getting smaller. That's a negative relationship. And if we look at the scatter plot in this regard, you can't tell whether it's going up or down. That is going to have no correlation, no connection or relationship. So this example would be, as we drive further, it's going to cost us more money in gas. This one would say, as we drive further, there's less gas in the tank. And this one would say, as we drive further, we would have more people in the car with blonde hair. There's no connection to it whatsoever.